Yes, so welcome to today's lecture series. I want us to look at a simple way on how we can be able to generate keys using the RSA algorithm. What I'm using Python, Jupyter Notebook, and can actually be got from the Anaconda distribution. And just to explain, my RSA algorithm comes from three people. That's Rivest Shamil, Adleman. And in this section, I'm going to take you through how we can be able to install specific modules, how we can be able to define functions, and how we can be able to import some libraries inside our work. And then as well, I'll take you through how we can be able to write some functions, which functions can help us be able to generate keys. So first of all, for your case, if you have not installed the Scriptodome module, I would actually recommend that you install it, and we can install it using the pip command. So I can say pip install py-cryptodome. Py-cryptodome. And if you press shift enter, if you don't have it, it will definitely install. You must be having internet. But mine already is satisfied, so meaning I already have that required package. The other thing is I'm going to import my necessary libraries. And the first library that I'm going to import is the base64 library. And then as well, from what I've installed, which is crypto, I would want to import an element of random to help me do the randomization of my keys. And then as well, from my crypto.public key, I'm going to import a specific algorithm that I'm going to use. And that algorithm is the RSA algorithm. And then as well, I can choose to import still from that crypto package some element of ciphering. And I'll use this specific library pkcs1 underscore 0 AEP. So sometimes this may not be desired, but you can put it, doesn't create nothing. I can see already my compiler here is rejecting it, which might be the case for most of you. So I think we can even choose. Let's just choose and we omit it just for some specific reasons. Else, let me check maybe with my typos. Good. That's our library that we're going to import. Other libraries, we can actually be able to instruct our system to be able to understand that crypto module. So I could say maybe from my sys, or maybe import sys, where sys.modules in brackets crypto will be equals to crypto. And I compile this as well. And I think there are all of my libraries that I will need preset. I could actually put this here so that I don't run so many shells that will not be of help to me. So all my packages there that I will need to use have already been installed. That means I'm really very much good to go. So the other thing that I'm going to do, I'm going to define my function. I'll define the functions which are needed. And the first case, I'll define the function that will take on a string and convert it to base64. And then next, I'll define a function that will help me generate keys. And finally, I'll define this function that will help me to return a pair of private and public keys. So let me define these functions in particular from here. So I could say from this particular case, let me define to base64 function, And what am I defining? I want it to be able to accept in some string characters. So if that's the case, that will be good enough. So what will it be returning? And a function that we define should be able to return something. Let it return base64 dot my base64 encoded string. Good. Spelling error should be very key. And that should be good enough for me to go. So that function will help me be able to take on a string and convert it to a base 64 character. The next function that I want us to take on is a function that will help me generate my keys. I want to term it as generate keys as a function. And what values are they taking? One, I'll need to define the length of my string that I'm going to take, the modulus length. And the modulus length should be a factor of 256. I could take 256 by 4, 256 by 5, 256 by 10, depending on how long you want your key to be. Then as well, I want to define my private key. My private key is going to be an RSA dot generate key as a function. And which variables will it take? It has to have two variables. One, it must take on the modulus length. And two, after taking on the modulus length, it must involve the concept of randomization. And as it is generating, it is new keys. And then three, I would want it to be read only, because those keys should be able to be read by a particular compiler that we put them to, so as to help us be able to distinguish them in their respective order. And then on the other side, my public key, you should as well be able to take on the private key and then return it, and then help it generate what a particular public key will be as a function. And I think with that, the parameters that I need are all good enough, to go. So meaning I should expect my function to be able to return these two values, the private key that I've created and the public key that I've created. The public key that I've created. I'm just doing a copy and paste. It's better so that we don't skip up. And when I press Shift Enter, we can all see that function runs perfectly. So these two functions, we have generated our keys, only that we cannot be able to display them, and maybe we need to export those specific keys. So let me get into my next case here. How do I generate these keys? Because I can't see them. The function is there. It's providing space for us to be able to have these keys, but how do we generate them? So let me generate my private and public keys. I'm abbreviating them as pre and pub. And from what I'm generating, I'll expect them to be able to make use of this function, generate keys. So if it is to make use of that function to generate keys, that means I would expect it to be able to generate for my keys. And there it runs when I press my Shift Enter. And finally, I will want us to export these keys, because it has generated them, but it's not displaying them for us. So what are these keys? So that thing that I expect it to do, I expect it to print for me my pre and pub that we have already generated. That's good enough. And then what is it generating this from? Maybe you can first run this. If we run it, you can see the output that it generates, which is quite a considerably good output. And probably I should be able to export these keys as well. And to export these keys, I would want to bring the export key function on both the private and public keys. So let me say my private will be equals to pre.export key as a function, and then also my public key will be equals to the pub.export key as a function. And if that is okay, that means I will have already generated my keys and I should be able to export these keys. So those are the keys that we already have. And if you look at that key is not in its proper form. It's not encrypted. And so somebody can easily be able to cram it. So the best option is we print these keys so that anybody who is going to get them will actually be able to make use of them. So I'm printing basically this private key, and I'm printing as well my public key. Let's see how they are going to look like before we can actually be able to do much. So if I press the Shift Enter here, we can see our keys are generated, but they are distorted. This is the private key somewhere ending here, and the public key is beginning. So why don't we separate them? We can separate this by putting in a new line function for separation, and we can use /n/n for whatever spaces we want. And then we end our quote and we shift enter. Now you can see when you do that, it raises a comment, and the comment is because of this public keys joining with this, so we need to put a comma here, and there we are good to go. So these keys have been separated. But all the same, if we look at these keys, they're having this B component, begin paragraph, so whatever it is, it's not helping us. We need to have it also omitted so that we have entirely keys that we are going to pick. So the best option is we need to decode these keys. So I'm introducing another function called decode on both the private and public key. And when I do that, I press Shift Enter. And I see my error, which all of us should be able to know. There is no dot here. And when I compile that, I have my keys finally generated. So, meaning if I have to encrypt any message using a given public key, this is the key that I'm going to export and use for encrypting my key. And a particular person that's going to decrypt my key, my message, will use this private key. Sorry, this is the public key, this is the private key. The public key is what we're going to use for encryption, and then the private key is what we shall use for decryption. And through doing that, we finally look at that our encryption algorithm, our private and public keys have been perfectly generated using the RSA encryption algorithm. In our next case, I'll want us to now be able to use this case and say how we can be able to encrypt and decrypt a particular message. That should be something that we're going to look at. Then probably I'll take you through the math of the RSA algorithm just to give you a good hint on. So for today, I close up this lecture. And in case of any comments, don't hesitate to post it on the comment section, and we can be able to freely discuss a lot of it there. Thank you so much. Have a great day.